with me? At the end of the day? All right. Okay, here's what I'd like you to do. 1.4 section is all about linear functions and slope. So let's begin the day by just brain dumping on what you already know about slope. Go ahead. Spit it out. What do you got? Rise over run. I love it. Good. That's a good one. Let's write that down. Rise over run. Good. What else? What else do you know? I heard a y equals an mx plus b. Good. What else did I hear? I heard point slope. Okay, we're going to talk about that today. What else you guys have? M. Very good. So M is equal to this rise over the run. Has anyone ever heard of delta y over delta x? Any physics people out there? Who's a physics person? Raise your hand. Let the record show only one person is raising his hand. Okay. Yes. Change. Delta means change in, right? So what's the differences of the y divided by the differences of the x, right? Very, very good. Okay. Let's talk about. Let's give you a context of a picture. So if I give you an xy coordinate plane, okay. Here's the x-axis. Here's the y-axis, and we give you some generic x value. And then we give you another generic x value, like x2. And we give you some y values over here, like y1 and y2. Give you some points associated with those, like this. Good. Good to go. Wonderfully straight line there. Okay. So how do I calculate? How do I get a formula out of this? How do I calculate the change in y? Izzy, what do you think? Yeah, that's the change in y, right? This right here, this difference is calculated by y2 minus y1. That's what that is. So the change in y is y2 minus y1. Sweet. What about the change in x values? How do I calculate this difference here? Yeah, that has a value of x2 minus x1. So that goes in the denominator. x2 minus x1. So that means I figured out this part, that's my rise. I figured out this part, that's my run. If I take the quotient of the rise to the run, then I have what's known as slope. I would like you to consider slope as a rate of change. It is a constant rate of change because it never changes, right? The slope of lines is always the same. That's the beauty of a line. And that's what makes them so easy and fun to work with. Okay, so let's have an interactive example here. I'm going to give you a coordinate plane, and you are going to produce for me any points that you want inside it, and then together as a class, we're going to calculate the slope. So, x and a y. All right, somebody give me any point in any quadrant. Just spit it out. 2, 4. Good. 1, 2, 1, 2, 3, 4. Boom. There is the point, and that's the point 2, 4. We agree with that one? Okay, give me another point anywhere that you want. Anywhere. Wait, did I do something wrong? 2, 4. 1, 2, 3, 4. I'm good. Oh, sorry. Thank you. 2, 4. Sweet. Awesome. Way to be with it. Okay, give me any other point. 0, 3. Okay, 0, 3, 0, 3. Boom. There's a point, 0, 3. How many points do you need to make a line? 2. I have 2. Awesome. Look at that. There they are. I'm going to then connect those right there. Great. Okay, so we're going to calculate the slope using the slope formula. So the slope formula is y2 minus y1 over x2 minus x1. And then we'll just look at it and interpret it from the graph. So y2 minus y1. Well, let's label these things, right? Here's x1. And y1, here's x2 and y2. By the way, could I have labeled those the other way around? Yeah, I could have, right? I could have labeled that other point x1 and y1 and vice versa. So what's the value of y2? 4, good. Minus, what's the value of y1? 3, good. What's the value of x2? 2, what's the value of x1? 0. So that gives me, 1 over 2? Is that right? So that's my slope. Hey, check it out. It's the same thing if I just go from up 1 and over 2. Sweet. That's it. Up 1, over 2. Take the quotient. That's my rise. So this particular slope happens to be positive. Why? How do I know that this is positive? It's going up. It's increasing as I go from left to right. This is a line. It always behaves the same, so the interval is always the same. What could I do to make this a negative slope? Has to be going the other way. So if I maybe had this point on the line and drew this blue line on here, that is a negative slope, right? How come? Because it's always decreasing, right? It's going from left to right, decreasing always, all right? Let's talk about let's talk about special slopes. So I'm going to give you any old generic x1, any old generic x2, and give you an output here and a point there. So boom, we'll have a drawn line going like this, and this is some y value up there that it's outputting. Okay. So how would you describe this line? What type of line is it? It's a horizontal line, right? Think of the horizon. It goes left to right. It's a horizontal line. Okay, let's try and calculate its slope. So the slope is delta y over delta x, which means y2 minus y1 over x2 minus x1. Well, what is the difference in the y's of this line right here? How many y's do I have? I only have one y value, right? The output is the same for any x value I have. If the output is the same, then how can I have a change in the y's, right? So therefore, this is going to give me 0 over WC. What is WC? You guys ever seen that? What do you guys think it was? Wash closet? No. Okay, so that says 0 over who cares? Because the answer is going to be what? 0, very good. Except, what is the one exception to 0 over who cares? Nope. 0, there you go. 0 over 0. What do we call that? We call that calculus. All right, we'll get there later. Okay. So right now, for all intents and purposes, for us, 0 over who cares is going to be 0 because it's going to be 0. That's the beauty of it. So that means that this line has a slope of 0. Okay. Don't say it has no slope. Say it has a slope of 0. Just like the floor, right? We would love the floor to have a slope of 0, right? We don't want the floor to have a slope of 2, because then all the desks would be sliding into one corner, and that would be terrible for a learning environment. So we say it has a slope equal to 0. Okay, that's in contrast to this drawing that I'm going to show you right now. So any old generic x1 right here. All right, go up and down. So I'll give you these 2 points right here. So here's y2, here's y1. What type of a line is this? This is a vertical line. So the change in y I can easily calculate. It's all of this stuff. That's no problem. That's y2 minus y1 over, what's the change in x? There is no change in x. That's 0. That's called bad. All right? Something over 0 is called bad, or actually what it's really called is undefined. An undefined slope. So some lines have positive slopes, some lines have negative slopes, some lines have slopes of 0, and other lines have slopes of that are undefined. Excuse me. Okay, feeling pretty good about this so far? So far, it should be a nice, good review for you. So when we talk about lines, we talk about different forms of a line. So the first form we're going to talk about is called point-slope form. The reason they call it point-slope form is because they give you a point and a slope. They make it super easy for you. So the generic breakdown is y minus y1 equals m, x minus x1. So let me dissect this for you. The y1 and the x1, this is going to be whatever point you're given. Some generic point, x1, y1, right? That's where you plug in to go. What is the m going to be? Now the slope, right? Boom, that's your slope. Hey, that's why they call it point slope, because they give you a point and then they give you the slope. So they call it what it is. The other piece, the y and the x, you leave these alone. These are your variables. We'll just write in point slope form. right, so we've been given a point or a slope of -2, and we have a point of 5. So if I want to figure out, put this into point slope form, I'm going to write y minus y1 equals m x minus x1. So start with the generic. Okay, then we're going to plug in my point, x1, y1. So I'm going to have y plus 1 equals the slope, which is -2, times x minus 5. And that is point slope form. Super easy, right? Okay, now, here's a bonus question. What if I were to keep going in terms of simplifying this equation here, y plus 1 is -2, x minus 5? What would happen if I keep going? Yeah, let's do that, okay? So I'd get y plus 1 equals what? -2x plus 10, yeah? And then, or subtract 1 from both sides, so what would I get? Okay, good. So if we keep going, right? So this one was point slope form, right? What is this one now? Yeah, what do we call y equals that? That was one of the things. Yeah, you guys brought it out right away, right? Back up in the beginning of the lesson. Yeah, what do we call this one? Yes, slope intercept. I wanted to make the point that these two equations that are highlighted in yellow are the same line, right? But they're just, they look different, but they represent the same line. So we're good, all right? So there are different representations of the same thing. So that's the last bit that we're going to talk about. Why do you think slope intercept, what do you think that's useful for? What's it useful for?
It's finding like the slope easily and the y-intercept.
It's very useful for graphing, huh? It's way easy, and we're gonna review that. So point slope form is not so useful for graphing, but slope intercept form actually is useful for graphing. So the generics, we'll just make sure everybody has it. Y equals mx plus b. The b part represents what? The y-intercept. The m part represents what? The slope. Very good. Okay. Just to make sure we're all covered with that. So for our last example here, we're going to graph f of x is equal to -2/3 x plus 5. Okay. Oh, sometimes this is written in function form. F of x equals mx plus b. Function form. But that's no big deal. That makes sense. So sometimes f of x takes the place of y in function form. All right, cool. So let's graph this. How do I do it? Yeah. If this stands for my y-intercept, I go up 5. 1, 2, 3, 4, 5. Boom, put a dot there. Then what do I do? Yeah, the slope is -2/3. So from my point 5, do I go up or do I go down? I go down. Very good. Go down to 1, 2 over 3. 1, 2, 3. Boom, put a dot. Okay? So I go down 2 units, so -2 units. I go over to the right a +3 units. That creates the slope, my rate of change of down 2 over 3 for my function. And this is what I would get out of it there. So I have negative slope. So let's write down the steps just really quickly. First thing, what did we do first to graph something in point slope form? What did we do first? Yeah, we would plot the y-intercept. All right. What's the second thing we did after we plot the y-intercept? Yeah, we apply the slope from the y-intercept, right? So you got to do the y-intercept first, and then from that y-intercept, apply the slope. What's the very third thing that we did? Yeah, connect the dots. Connect the dots. So there you go. There's our process. That's terrible dots. Whatever. It sure does, huh?